Hello everyone, my name is Chung, and today I'm presenting my final project for data analysis using Python. My project topic is going to be about Los Angeles citation analysis, and I'm going to let you know why I picked this topic. So why I picked this topic? So have you ever wondered why sometimes you can talk out of the parking citation but other time not? It happened to me before where sometimes it will be easy for me to just talk it out and officer would let me go. Sometimes they would just refuse to even talk to me and just write me a ticket and walk away. So I wonder whether they have a monthly quota to fulfill. And if so, when is the deadline that uh, the quota that they have to fulfill is going to be by? And I'm also going to be looking at some other parking citation trends, such as what color vehicle received most of the citation, what citation time is issued the most. So, for example, whether they issue most of the citation during the morning time or during the night time or evening time or whatnot. So this is the way I'm gonna approach it. So for my input data, I source my data from Cargill.com, and they actually maintain Los Angeles city data, and the data is a CSV file, and it's a very large file. It's about over 1 GB, and then after I got my data input, and I'm gonna do some manipulation to in order to process the data, because the data format might not fit the pandas requirement. So I'm gonna do some of that, and then after that, once I manipulate it and process it, and I will have my outcome. I will present it in a sorted data format, so a series, in a column or in a chart. So first, my input. So as I mentioned earlier, my input is a raw CSV file, and it's about 1.2 GB. The range of the data is ranging from 2014 all the way to 2019, I believe, early March. So the data set is huge, and the trend that we see should be fairly accurate. And what you can see here is the first column is going to be the ticket number. So every ticket number is going to be unique. So we can do our count with the ticket number, and then issue dates, time, uh, and so on and so forth. And yeah, so first I want to look at how want to look at what dates received uh, uh what dates parking officer issue most of their citation. That way we can see whether they have a monthly quota to fulfill, and when is the monthly quota due. So in order for me to do that, I first have to manipulate the issue dates format. So first, I um I ish I strip off the unnecessary 00 uh semicolon 00, because that is just the daytime that for whatever time that for whatever reason remain. So first, uh in in uh in this line right here, first I strip it off with a string r strip function, and then after that I replace all the dashes with a empty string. So everything, so once I do that, it's gonna read 2015 12 21 rather than 2015 12 21. After that, I convert the string to a timestamp using the to dates time function, and then I specify my format. And after that, I use the head function to just preview the dataset. Since the dataset is huge, It's just gonna take too long of a time to run it through. So now you can see the issue date is correctly displayed, and it is in timestamp format rather than a string format. After that, I create a new column only showing the date. So the new column, I use the lambda expression that I found online. It will only contain the date. So for example, it will only show 21, 26, 15. So I know what dates of the month tickets were issued. And then after that, I use a group by function with the new column. So I group the new column that I just created by the ticket number, because ticket number is unique for every single one. And then I can do a count, and then after that I sort it in a descending order. So it will show it will show the number of citation received the most to the least. And then the results, as you can see, I have used matplotlib library, and then I plot it into a bar chart. So as you can see, on the 2nd of each month, that's the day that most tickets are issued, followed by the 1st and then the 3rd. However, the end of the month is actually the least amount of ticket issue. So my assumption of the end of the month is the deadline is incorrect. So my assumption is that after reviewing this data, I'm predicting that the deadline is probably at the end of the 3rd of each month or the beginning of the 4th of each month, because right after the 3rd of each month, the number of citation drops significantly. So you can see it almost dropped like 40% from the 3rd to the 4th of each month. So perhaps they have a quota to fulfill, and the cutoff date might be on the 3rd of each month. So now I'm gonna do a live demo for further findings. So here I have Juniper notebook open. So I first import pandas as PD. I import numpy as np. It's probably unnecessary, but I just do it anyway. And then I import matplotlib as a plt. So this part is I use a read CSV function to read in a CSV file. And then you see the warning sign right here is because the file is too big, and I tried to use the chunk size member function, and it wasn't working. So this is just showing that, you know, I the memory, I have maxed out the memory because the file size is just ginormous. And I use a head function just to preview the the data set. And this part I've just covered, you know, to clean up the dates or whatnot. And then now I'm going to talk about, you know, each violation code, and I also sort it in a descending order. So first, I group the data by the violation code, and then I do a count on the ticket number. As I mentioned earlier, ticket numbers are unique, so that way I know what ticket numbers received the most ticket and the count and such. And then I sort it in a descending order. As you can see, violation code 80.69 BS, 88.88.13B plus 80.56 E4. Those are the top three, and then the 80.58L is the fourth. And then and I have to go down. So I just looked it up a bit online, and then And this is the violation code. For the first one, the most issue citation is parking prohibited and for street cleaning, followed by overuse of a meter. So you forget to feed your meter, you forgot to your meter expire and such. And then the third one is actually no stopping zone. So red zone. Actually, I'm kind of surprised that this is the third issue citation. So people just park in red zone and they just get ticket. And then the fourth one is the preferential parking. So I assume this is gonna be perhaps handicap parking. So maybe you park at a handicap parking slot without a permit. And then I also look at what time tickets are issued most during a day. So first I look at the issue time, and then because there's some of the time the data, there's a NaN within the data set. So first I fill in all the NaN with 0, and then after that I convert the floats to int in order for me to drop all the floating points. So I do that, and then after that, so first I fill in all the on all the NaN, and then after that there's still floating point, and with floating point there's a dot. I cannot convert it to a timestamp, so that's why I then convert it to integer, and then from integer I convert it to a string, because in order to convert to a datetime object or a timestamp, it needs to be in string. And then I add the leading zeros to the string so they're in the right format to be parsed to a timestamp object. So for example, it might be 1 o'clock in the morning, 1:15. For that, the to timestamp to datetime function is not going to be able to parse it. So I add a 0 in front, so that way it knows the correct format. And then after I fill in at leading zeros, then I convert it to a string. Then I convert the string to timestamp object, and then I specify my format, and then I check the type using an ilog, looking at the index 0. So it shows that now it is a timestamp object. And then as you can see, now it reads in correctly, and I basically ignore the dates because that's not what I'm focusing at. And then I create a new column for the issue hour rather than just focusing on this part right here. So I use a lambda expression again, and then this is a new column that I just create called issue hour. And then and then after that issue hour, I group the issue hour by the ticket number again because it's unique, and then I sort it in a descending order. So you can see most of the tickets are issued at noontime, 12 p.m., followed by 8 a.m., 10 a.m., and 11 a.m. So most of the tickets are actually issued between 8 to 12. And then after that, it just evens out. And then the least amount of tickets that issue is, sort of obvious, is from 11 p.m., 3 a.m., 4 a.m., 5 a.m., and midnight. So 5 a.m. is the time that tickets are least issued. And then I also looked at the color vehicle we received most of the tickets. So this is fairly simple. I just group the data by the color, and then I do a count on the ticket number as mentioned earlier. So the most the color that received most of the tickets is black car, followed by a white car, gray car. But this is sort of it's not telling us much because obviously a lot of people simply just pick black car, so it doesn't mean that uh black car is the most popular. It's simply because there are more black car than yellow car on the street. So this is basically my final project for the class. Um, and I want to go back to this part right here. I had a lot of trouble trying to figure out how to parse the dates. First, I use to datetime function and then following this exact thing, and then it wasn't working. And after looking online, and trying different thing, I figured that the dashes was causing all the problems. So the to datetime function wasn't able to read in all the dashes, even though I removed the t everything, even though I removed everything after the digit 21 right here. So all this highlighted, I removed it. Even then, it wasn't the function. The method, the to datetime function wasn't able to parse it. So then I realized, I do have to strip this off. So after I stripped this part off, the datetime function was able to function, and then I got this. So that was pretty interesting. Um, what else? I found the plot chart. The bar chart is actually fairly simple to use. As long as the column and index are correctly labeled. This I didn't really have to do much. Literally just plug in the column that I'm trying to read in, trying to show, and it does the rest. This part is very simple. So I see that I assign raw data group by to this variable, and then I assign it this part to the same variable again. So I'm assuming there's probably a more efficient way to do this. So there's probably a way where I can merge these two lines of code into one. um, for the time is also quite interesting. Um, to parse it, I was having trouble because the issue time, um, the format of issue time is very weird. So it shows like 1251.0. So this is causing a lot of trouble because I wasn't able to do much. I wasn't able to use the function at all because of the dot zero. So I have to strip this off. But then also, uh, with 3 digit remaining, it also was causing problem because it's not the 4 digit number. So then I Google it, and then I found a solution where I have to add in adding leading 0 up to 4 digit. So here you can see string C field 4. So this is field up to 4 digit. Up to up. This is the length of the string. So I do that, and after that everything just went very smooth, and then I can just simply parse it, and then that's about it. So yeah, so this is the end of the project. I found pandas to be very very useful, as well as the bar chart, the matplotlib, very useful. Um, so yeah, this is it. I hope you find the information interesting. Thank you.